Hello dear students, you are welcome to RK Institute. I am Dr. RK Sainik and today I am going to posting 10 more questions about physical chemistry, particularly chemical kinetics. As you know, I keep posting 10 important questions on a topic from my channel, and these questions asked in different examination like as IIT-JEE, NEET, JRF, UGC, even IAS-UPSC. Some questions including IPS, UPSC also. I think these questions help to improve your chemistry as well as to understand basic concept about the chemistry. And today I am going to discuss 10 more questions of physical chemistry, namely chemical kinetics. Okay, question number first. Question first. This question asked in UPSC in last year. UPSC 2024. Activation energy of the decomposition of H2O2 gives H2O plus O2 gas is 42 kilojoule per mole, whereas the reaction is catalyzed by enzyme, it is 7 kilojoule per mole. Calculate temperature that would cause the uncatalyzed reaction to proceed rapidly as enzyme catalyzed. It means calculate temperature when this reaction as rapidly as in presence of catalyst, when their activation rate is 7 kilojoule and temperature is 20 degrees centigrade, then we find temperature for uncatalyzed reaction by which the reaction will be same in speed. Whereas when rate is same in speed, then rate equals to K into concentration of H2O2 power 1. When rate is equal, it means rate constant is equal. Therefore, K in absence of catalyst and K in presence of catalyst. And we know that Arrhenius constant K is AE minus EA upon RT. It means EA upon RT is equal. Putting the value EA in absence of catalyst R into T, and EA in presence of catalyst upon R into T. Given value EA in absence of catalyst given 42 kilojoule. R is constant and we find temperature at which reaction become fast as rapidly as in catalyst, and the activation energy in presence of catalyst is 7 kilojoule, and R and temperature 20 degrees centigrade. 20 degrees centigrade convert into Kelvin at 273.15. Therefore, T is 293.15. On solving this equation, R cancel to R cancel to R, and 7 6 is 42. Therefore, T is 293.15 into 6. This value in Kelvin is 1758.9 Kelvin, or we report in answer in degree centigrade, then subtract 273.15 degree centigrade. Therefore, your answer is 1485.75 degree centigrade also. This question is from UPSC, particularly IS in last year. Question number next. Question second. Question number second. This question is asked in JEE. A and B, two substance undergoing radioactive decay in a container. Half-life of A is 15 minutes and B is 5 minutes. Initial concentration of B is 4 times that of A, and they both start decaying at same time. How much time will take that concentration of both of them to be same? First, we read question carefully and then use given values, and then find questions for the time. According to first law according to chemical kinetics, the radioactive decay of a first order kinetics, and the first order kinetics is decay constant into T. They are integrated at equation ln initial amount or time t, or we can say initial radioactive nuclei, where the term is used concentration also. In equation first, for substance A, half life is 2. We know that radioactive decay constant or rate constant is ln2 upon half life. Therefore for A के लिए the decay constant ln2 upon half life 15 into t, ln a naught upon nt. For second, ln2 upon 5, their half life is 5 minutes. For B, this equation for A, initial concentration of A and concentration of A after time t, concentration of A after time t. And for B, ln2 upon half life into t equals to ln initial concentration of B and their concentration t. In given question, the initial concentration of B is 4 times that of A. It means 4 A node. Suppose initial concentration of A is N node, then the initial concentration of B is 4 times. And the time, and we require time by which concentration both become same. It means NT equal. Equation 1 and equation number 2. Equation 1, from equation 2, we subtract equation 1. Then ln2 upon 5 into t minus ln2 upon 15 equals to ln 4 n node upon nt minus ln n node upon nt. On solving this, ln 2 into t taken common, and 1 upon 5 minus 1 upon 15 equals to ln 4. Only ln 4, because n node cancel and nt also can be. Or for ln 4 equals to, we write 2 ln 2. 4 equals to 2. 4 equals to 2 की power 2. Therefore 4 ln. And on solving the t equals to 2 ln 2 divided by ln 2. And on solving this problem, the LCM is 15, and by 15, 3 plus 1, 4. Therefore 4, 15, LCM 15, 3 minus 1. Therefore 2 upon 15. Therefore this value is cancelled out and the answer is 15. The answer is 15 minutes. Okay. Question number second. Question third. This question also asked in JEE. Adsorption of hydrogen on platinum is the activation energy is 30 kilojoule. And the adsorption of hydrogen on nickel gas is same, hydrosorption, and the substance are different. One is platinum and another is nickel. The activation energy is 41.4 kilojoule per mole. Logarithm question: the logarithm of the ratio of the rate of chemosorption are equal, whereas the on equal area of the metal at 300 Kelvin. It means rate of adsorption is directly proportional to rate constant and the pressure of hydrogen gas. The pressure of hydrogen gas is also equal. It means their rate become equal. In most of the cases, adsorption of gases obey zero order kinetics. Therefore, it is zero order kinetics, and rate equals to K. And rate of adsorption of hydrogen and on platinum upon rate adsorption of hydrogen on nickel surface equals to K of platinum upon K of nickel. And we know that rate constant equals to A e raised power minus EA upon RT upon A e exponent power EA upon RT. On solving this, taking ln ln rate adsorption on platinum to the rate adsorption of nickel equals to minus this value is E1 and this value is 2 minus EA1 minus EA2 upon RT or we can say log rate of adsorption on platinum surface to the rate of adsorption of nickel surface equals to E2. EA2 means activation energy on nickel surface is 41.4 kilojoule and adsorption energy on platinum surface is 30. EA1 divided by R into T. R ln, when change ln into log, then multiply 2.303 but given 2.3, therefore 2.3, and hence logarithm of radium is 2.3 into R. 2.3 into R, given value is R 8.3 in joule. Therefore, first activation energy also change into joule. And temperature given in Kelvin. On solving this equation is nearly, your answer is 1.99. On integer we write 2. We write 2. Solve this equation. Question number 4. Question 4. Consider the following reaction. Give from A to B in 3 steps. The graph is following type. For A, this is the graph for A. And for step second, the graph is given such type. And for third step, the given graph is following. It is product B and start from A. Question. Choose the correct statement. The number of intermediate species. The intermediate species are 2, namely first step between first and second intermediate species A and step second and third 2. Therefore, the number of intermediate species are 2. Next, number of activated complex. The highly unstable, loosely bonded, high energy species known as transition state or activated complex. Therefore, 3 activated complex are there. Activated complex 1, activated complex 2 and activated complex 3. Number of activated complex are 3. Number of intermediate 2, number of activated complex 3 and redetermining step. Redetermining step is second. The step where high value of activation energy is slowest step, and we know that slowest step is RDS, or we can say redetermining step. Therefore, your answer is B. Question number 5. Question 5. The number of given statement which are correct is: first, the stronger the temperature dependence of the rate constant, the higher is activation energy. We know that according to Arrhenius equation, K equals to A E raised power minus activation energy upon RT. If higher value of activation energy, the higher value of activation energy, it means rate constant is very less. And when rate constant is very less, then reaction is hardly proceed. Therefore, the K is mainly dependence upon the temperature, and hence we raise the temperature, then increase the value of K. It means the first statement is correct. The stronger the temperature dependence of rate constant, when higher value of activation energy, it is correct statement. If the reaction has zero activation energy, the rate constant independence upon the temperature, it is also correct. If activation energy is 0, suppose activation energy is 0, then this factor is mathematically 1. E raised power 0 means 1, and hence K become constant, does not depends upon the temperature. It is also correct. The stronger the temperature, dependence of the rate constant, smaller the value. It is incorrect. There is no correlation between temperature and rate constant. That it means that is reaction has negative activation energy. Activation energy never be negative because activation energy is extra energy. Minimum extra energy supplied to the reactant molecule by which their collision become effective. Or we can say the fraction of effective collision becomes equal to the Barth-Load factor, and hence activation energy never be negative. Only two statements are there, namely A and B. Question number 8. Question 6. A molecule undergo two independent first order reaction whose respective half-life is 12 minutes and 3 minutes. Both reactions are occurring. Then the time taken for 50% consumption of the reactant is in minute mein. It is the example of parallel reaction. Reactant A parallelly decomposed into B and parallelly into C. It is the example of parallel reaction. And we know that the rate constant of rate constant of A to B is K1 and rate constant of B A to C is K2. And their average rate constant is K1 plus K2. And hence, according to first law, the half-life equals to ln2 upon K, or where K is K1 plus K2, means average half-life, average rate constant ln2, putting the value ln2 upon K1 equals to ln2 upon given half-life is 12 minutes, plus K2 ln2 given half-life is 3 minutes. On solving the equation, we find following time for 50% consumption. Half-life T half equals to ln2 and taken ln2 common, therefore 1 upon 12 plus 1 upon 3. Taking LCM, 12, 1 plus 4, and hence half-life equals to ln2 upon ln2 into 5 upon 12. And hence your answer is 12 upon 5, or this answer is nearly 2. Actual answer is 2.4, but we write in nearest integer. Therefore, we mark 2. Question number 6. Question 7. The number of incorrect statement the following. Pehla, the successive half-life of zero order reaction decrease with time. It is correct statement. First, successive half-life, suppose the initial concentration of 0.4 m. After one half-life, their initial concentration is 0.4. After second half-life, concentration become 2 m. And we know that these are the half-life. And we know that half-life is directly proportional to the initial concentration in case of zero order reaction. Therefore, half-life decrease when decrease the initial concentration. It means this T1 first, T half first is greater than half-life in second part. And as statement is first is correct. Half-life directly proportional to initial concentration. Initial concentration 0.8 m, half-life greater. Initial concentration 0.4 m, half-life less. First. Question 8. Given equation. If the above reaction was studied at 300 Kelvin, monitoring the concentration of ferrous sulfate in which initial concentration 10 m, after half an hour become 8.8 m, the rate production of ferric sulfate is in this term. First, we write ROR, relative rate of reaction, the disappearance rate of ferrous sulfate divided by their stoichiometric coefficient, then relative rate. And in case of ferric sulfate, formation rate. Ferric sulfate, their formation rate divided by their stoichiometric coefficient. And it is known as relative rate of reaction, or we can say equal rate. given value. This value is given and we required formation rate of this. Therefore, this value, change in concentration given 10 m minus 8.8, and the time taken is half an hour, 30 minutes, negative sign. Therefore, concentration become positive, and hence change in concentration 1.2 in 30 minutes, or we can say into 60 second, and divide by their stoichiometric coefficient. Simplest coefficient is 2. Then we find rate production of ferric sulfate, Fe2SO4 thrice upon dt, and our aim is rate formation of ferric sulfate. On solving this question, we obtained your answer 3.33 into 10 की power minus 4. We write in term of 10 की power minus 6. Therefore, the answer is 333 into 10 की power minus 6, and hence your answer is 333. Question number 8. Next, question 9. Question 9. A chemical reaction A to B give product order 1 with respect to A and B. Find X and Y. So we know the equation from experiment 1 divided by 2. Rate 0.1 divided by 0.4 equals to K, concentration of A की power 1 and B की power 1 divided by K, concentration of A की power 1 upon B की power 1. On solving this, 0.1 divided by 0.4 equals to K cancel, A 20, we find X, and B 0.5. Therefore X is 80. Multiplied by 4. Now experiment first divide by third, then find Y. Similarly, experiment 1 divide by third, rate 0.1 divide by 0.8. In experiment K is also cancelled. In concentration of A is 20. In third experiment concentration is 40. In first experiment concentration B is 0.5, order 1 है, and Y. Therefore K cancel, 2 cancel 2, or Y equals to 4 by 2. Cross multiply 4 by 2, or we can say 2. Therefore your answer is first. Question 10. The reaction given takes place through the following mechanism. We know that the slowest step is known as RDS, and hence we write rate according to slowest step or RDS, rate determining step. Therefore the rate is directly proportional. There, suppose the rate constant is K1. Rate constant is K1 and the concentration of NO Br2 and concentration of NO, because for given steps are elementary and the order of species is equal to their stoichiometric coefficient, but NOBr2 is not a reactant because it is intermediate species, because it not present in the reactant. Therefore, it must be replaced from another step. For example, in step first, the rate formation, rate constant for forward reaction and rate constant of backward reaction equals to concentration of NOBr2 according to law of mass action, and concentration of NO into concentration of Br2. Putting the value of NO Br from this equation, and as finally we write rate equals to K1 into Kf into Kb. Kf, Kb are rate constant for forward and backward reaction for reversible process, and hence NO Br, the concentration of NO into concentration of Br2 and concentration of NO also. Therefore the order is 1 plus 1 plus 1, or we can say it is third order reaction. The overall order is third. The answer also given for this question, these questions, and are therefore. In another lecture, we also posting 10 more questions of important topic. Okay, bye.